Welcome to today's demo showcasing a lightweight Java diagnostic tool designed for AKS. This tool is easy to deploy using Helm and comprises two key components, a controller and an agent service. The controller integrates seamlessly with the Spring Boot admin server, reconciling custom resources, CR, to automatically discover and register applications within the same namespace on the dashboard. Meanwhile, the agent service dynamically attaches agents to your running applications, enabling efficient diagnostics and troubleshooting without restarting any application. Let's begin the demo. First, we'll examine the existing customer workloads on this AKS cluster. Let's list them. As shown here, there are 3 applications currently running as deployments. Each deployment is paired with a cluster IP service bearing the same name. Next, we'll proceed to install the Java Diagnostic Tool using the Helm install command. As indicated, the tool will be deployed in the ASA system namespace. Now, let's review the newly created resources in the ASA system namespace. Excellent. Both the controller and the agent service have started and are running. Next, we'll install the Spring Boot admin server by applying a custom resource displayed on the left side of the screen. This resource defines a component named sample_sba, which will run in the same namespace as the existing customer workloads. Now, let's review all resources in the ASA apps namespace. Great. You can see that a deployment named sample_sba Azure Java has been created, along with a corresponding cluster IP service of the same name. Since this AKS cluster does not allow public access, we'll perform port forwarding operations for both the target demo application and the newly created Spring Boot admin server before proceeding. I'll forward the demo application to localhost on port 5555 and the Spring Boot admin server to localhost on port 6543. Finally, let's access the Spring Boot admin dashboard via localhost. Great. As shown on the Spring Boot admin dashboard, all workloads within the same namespace have been automatically registered and displayed. The Node.js application, lacking the necessary actuator endpoints for Spring Boot admin integration, is marked with a down status. In contrast, the other 3 Spring Boot applications, each running with 1 or 2 replicas, are all shown as up. Now, let's explore the demo application for more insights. Here, you can monitor real-time metrics such as garbage collection activity, heap and non-heap memory usage, and more. Additionally, you can dynamically adjust the log levels for any dependency in your application. For example, switching to the debug level provides detailed logs for in-depth troubleshooting, while switching to the error level helps minimize unnecessary verbosity from certain libraries. These changes take effect immediately at runtime without requiring an application restart. Furthermore, you can generate real-time thread dumps and heap dumps to help diagnose and resolve complex issues effectively. Next, let's explore the source code of the demo application. The application includes 2 RESTful APIs. One is a put API that simulates a real-world customer scenario. It invokes 3 functions: validation, access database, and filter data, each of which logs a message to the console. The other is a post API that introduces a performance issue in the access database function by adding a 3-second delay before logging. Additionally, we've implemented a custom health indicator to correlate the application's health status with the presence of any performance issues. Now, let's monitor the logs of the demo application. Since we've already set up port forwarding for the demo app, let's send 2 put requests to the application via localhost. As you can see, both requests completed in under 1 second. The console logs confirm that each put request traversed the 3 functions validation, access database, and filter data, with corresponding log messages. Next, let's configure a metrics monitor on the Spring Boot admin dashboard for this put API. The results show that 2 requests were made, with a maximum execution time of just 4 milliseconds. Now, let's invoke the post API to introduce the performance issue. Subsequently, when we invoke the put API again, you'll notice from both the dashboard metrics and the HTTP response that the execution time exceeds 3 seconds. Finally, let's review the health status of the demo application. Thanks to the custom health indicator, the application's instance health is marked as down, while the readiness and liveness statuses remain unaffected. Now, let's further investigate the source of the performance issue using the agent service. First, we'll set up port forwarding to enable our local IntelliJ instance to interact with the agent service pod in AKS. Next, we'll open the Java Diagnostic extension in IntelliJ. Here, we can see a list of all pods in the target namespace, AC apps. We'll select the target application, demo app, and attach the agent to it. Since multiple containers can be attached simultaneously, we'll designate demo app as the active one for interaction. Now, let's begin troubleshooting. From the Spring Boot admin dashboard, we know that the application is unhealthy and that the put API takes over 3 seconds to complete. We'll start our analysis with the put API function, which, as shown in the source code, invokes 3 submethods. To identify the issue, we'll add surrounding logs to each of these methods and observe the results. The logs have been added successfully, and we can also see confirmation logs on the left indicating that the agent has been attached. Let's trigger the put API once more. This time, the application console logs display additional start and end logs for each of the 3 submethods. The logs reveal that the access database method takes 3 seconds to complete. We've successfully pinpointed the performance bottleneck to the access database method. Finally, we can remove the additional logs with a single click. Let's trigger the put API again to confirm. The additional logs are gone, leaving the application log clean as before. This demo showcases a straightforward example of diagnosing a performance issue that developers might encounter. It demonstrates how the integration of the Spring Boot admin dashboard with the agent service provides a simple yet effective troubleshooting experience. That concludes my demo. Thank you for your attention.